This is Teresa Jacobini from Citus Data, and I'd like to welcome you to our live demo, 10x Faster Analytics Queries on Postgres with Citus. As you know, Citus is in the business of making it so developers like you don't have to worry about scaling Postgres. Today, we're going to give a live demo focused on showing how you can get that 10x better performance on your analytics queries. Samay Sharma, an awesome engineer here at Citus, is going to be your host and give the demo. Samay has been here about 5 years, and he's worked on new features for Postgres, documentation, and also worked with lots of customers getting them up and running. And now, without further ado, I'm going to turn it over to Samay.
Thanks, Teresa. Hey, everybody. So before we start with the live demo, I just wanted to walk through a few slides to give you an idea of what Citus is, how you can get it, how you can play around with it. So just wanted to walk through a few basic slides. So we at Citus are big fans of what Postgres can do for people and for their application. Postgres has grown to be one of the most popular open source relational databases in the world, and for good reason. A lot of our customers are using currently Postgres and then want to learn more on whether they can use Postgres for higher, let's say, throughput workloads, higher performance workloads, and higher data sizes, which is why we've built our entire database product based on top of Postgres. You should have a poll pop up on your screen. Just wanted to get an understanding of whether how many of you have used Postgres in the past, not yet used it, or have tried it out, or have deployed it in production. I'll just give you 2 seconds, 2-3 seconds to vote on it. Okay, looks like most of you have the votes in, so around 75% of you have already used Postgres and deployed it in production, which is great. And I hope most of the things I say will resonate with you because you're pretty familiar with the Postgres world. For those of you who haven't, I think you should really go ahead and deploy Postgres in production. It's a really awesome database to work with. So today's demo is going to be about Citus Cloud. Citus is an extension to Postgres, which distributes your data across any number of nodes. It transforms Postgres into a distributed database such that from your application, it seems like a single large Postgres instance. But behind the covers, your data is split across the different nodes, and your queries are also split when you run them across the different nodes in the cluster. We are going to be doing this demo using a Citus Cloud cluster. Citus Cloud is our fully managed database as a service. A couple things to note about Citus. Citus is not a fork of Postgres. So we've packaged Citus as an extension. So we hook into the APIs which the Postgres ecosystem provides to us to provide all the functionality which we will be demoing today. What that means for users is that Citus is always in sync with new Postgres features. So whenever new Postgres releases come out, the extension APIs are fairly stable. They don't change very often. And that's why we don't have to spend a lot of effort trying to bring Citus back onto the main line of Postgres. That also means that you can continue to leverage your existing Postgres knowledge and expertise to use Citus. You can use your Postgres tools, whether they are more monitoring, whether there are other extensions of Postgres which you are using already, things like HLL, things like another extension we've authored, which is CStore. So all of those would be compatible with how Citus works. One example was a JSON. It was a feature which our customers had been requesting for a while. And then as soon as Postgres had it, our customers were asking us, when can we use JSON? And the answer was right now. To your application, as I mentioned, like similar to the Postgres tools and the ecosystem, even to your application, Citus will look like Postgres. So whatever we do today, we're going to do a side-by-side comparison on a non-distributed table and a table which is going to be distributed across a cluster. And then we'll run the exact same SQL for executing the query. and then Citus will take care of the sharding and the query execution transparently for you. The core Citus extension is open source, so you can find us on GitHub. Please star us. We'd really like for you guys to show us more love. You can use Citus in 3 ways. You can get the product in 3 ways. One, as I already talked about, the open source edition. You can download it, install it on any machine of your choice, and try it out. We have an enterprise software which comes with a few features in addition to the open source software. That includes the shard rebalancer for increasing the cluster size without any downtime and adding more nodes to your cluster. It gives you features to control data placement and isolate hotspots in your database. And it also comes with fine-grained access controls. The third flavor, which is what we're going to be using today, is Citus Cloud, which is our fully managed database as a service, where we take care of setting up databases for you, monitoring them, making sure that they're always up and running, and providing all the visibility you need to help manage your database. If you're not very familiar with Citus, there's generally 2 use cases where people use Citus. In overall, because Postgres services a wide variety of use cases, the same thing goes for Citus as well, because we scale Postgres out. But if you look at patterns, there are 2 which are major. One is multi-tenant systems of record. So these are fast-growing SaaS applications which are hitting the ceiling on single node Postgres, whether that's due to performance, whether that's due to the amount of data or the concurrency. So Citus helps you to use the power of multiple nodes to continue to scale without having to re-architect your application. The second kind of use case is real-time analytics, where you have billions of records of data and you want to have fast responses for them, ideally sub-second or single-digit seconds. And then what we're going to be doing a demo of today is more on the analytics side of things. So we'll be talking about how Citus parallelizes your queries to be able to give you these kind of responses. So before I dive into the demo, just wanted to walk through a few terms which you'll be hearing today. We'll be using the word formation, which is a terminology we use to refer to a Citus Cloud cluster. And when I say a Citus cluster, it consists of 2 types of nodes. The first one is the coordinator node, which is going to be the node with which we will interface with. And even when you deploy Citus in production, the one which your application is going to interface with. We also have worker nodes, which actually store your data. So when you interact with the coordinator will send and route your data to the appropriate worker nodes. And then when you run queries, it will route those to the worker nodes as well. We will be talking about shards, which are nothing but smaller PostgreSQL tables, which Citus will create behind the covers on the worker nodes. We will be using explain, the explain syntax, to look at different plans. Databases generally have an explain feature, which helps you look at the query plan. We'll be using that to see where the speedups are going to come from. We'll be using a JSON B column and we will query it. That is a binary JSON representation in Postgres. And one of the key benefits of it is reading it is super fast. And also you can create GIN indexes on it, which are inverted indexes, which allow you to query within individual fields in the JSON object as well. So just to walk you through what we'll be doing, we're going to be creating a few tables and loading data. We'll create a B-tree index, a GIN index on those tables. We'll run a query which is going to just touch a single node, and then we'll run another query which is going to join multiple tables together. We'll run both of them on single node Postgres and also with Citus extension enabled. And we'll see how the performance looks like for that. What I've done in preparation for the session is already set up a 4-node cluster with each machine having 8 cores each. And then we have a coordinator server which has 4 cores and about 7.5 gigs of RAM. So with that, I'll move to the demo. So this is the Citus Cloud Console. What you can see here is how you can create new databases if you'd like new formations with Citus Cloud. We have development plans which start from $99 a month. All of your Citus Cloud clusters are built by the hour, and we do that like it's a pay as you go kind of a model. So if you want to just quickly spin up a Citus cluster, test out a couple things, and then shut it down, you can do that at very minimal cost as well. These are development plans, and in production plans, you have the slider. So this is what I use to spin up the cluster we talked about. You can choose how many nodes you want in the cluster, what do you want the size of each node to be, and how much storage you want per node. So I'm going to switch now to the formation which I created in preparation for this session. You can see that we get a connection string from Citus Cloud. This is your standard Postgres connection string, which you can deploy in your application, which you can deploy and use to connect with pSQL, as I'm going to do right now. So I have 3 terminal windows open here. I'm going to connect to Postgres on this particular window, and then I'm going to open like a few scripts to copy over commands. Is this size visible, or maybe I should raise it a couple notches just to make sure it's visible to everybody? I'll do that for all the windows as well. Okay, great. So now we are connected to the Citus Cloud cluster. As you can see, this already has the Citus extension, the latest version of it installed. What I will do now is basically show you a couple of preparatory scripts which we will run. This demo is primarily about like read performance, but we'll also enable timing right now just to get an idea of how much time things are taking. The data set we're going to be using for this demo is going to be the GitHub events data set. And this is going to set up a single node Postgres table and load some data into it. It's standard Postgres, so I'm just going to go ahead and run this, and then we can talk about the schema and what the tables represent. Okay. So the data load takes about a minute, minute and a half. That should give us enough time to talk about the individual tables and what they are, what they stand for. So this is the GitHub events dataset. So GitHub actually makes all the events on public repositories downloadable for analysis. So that's what we're going to be using for this demo. I've modeled that data as 2 tables, the GitHub events table and the GitHub users table. The GitHub events table basically stores each row. Each row basically stores one event in GitHub. So let's say somebody created a new repository, somebody decided to comment on a pull request, somebody decided to create an issue. All of those would be different rows in the GitHub events table. It has an event type, which kind of captures the information I was talking about on what kind of event it is. And then it stores relevant information in a payload JSONB field. So the payload field basically stores different information depending on what the event type was. So let's say if it was an issue or a comment, it would store the text of that comment or the text of that issue. If it was a repository creation, then it will store some metadata about the repository creation, so on and so forth. The second part of a second table which we talked about is the GitHub users table. The GitHub users table is more straightforward, where it has a user ID and then the avatar of that person, the login name, etc., etc. And we use standard Postgres copy to load data into the cluster. Okay, so we're done with the preparatory script for the single node. I'm going to run it for the Citus tables as well. And let me display to you what that contains. So it's almost the same. There's just one difference in which is the create distributed table command. And I'll walk you through what it does once I've run the script. So as you can see, this script is very similar to the previous script, which is kind of because we've packaged Citus as an extension. So we use the same APIs as Postgres. One thing I've changed is I've changed the table name to include _dist so that we can differentiate that this is a distributed table, and we can query both of them on the same cluster. And then what the other thing which is different is the create distributed table command. So until we run that command, it is all standard Postgres. Once you run this, Citus will decide to create shards for those tables on the different data nodes we have in the cluster. So the 4-node cluster which we have, each of them will house a few shards. And another thing what this will do is it will tell Citus to intercept the queries which come into for these tables, and then we will basically process them as if they have to be executed in a distributed manner. So as an example, the copy command, you ran the command against the Postgres table, but Citus split it up across the different shards you have in the cluster. So looks like this completed. So as you could see, the loading process for the larger table took about 90 seconds on the single node system, whereas on distributed tables, the same amount of data took about 37 seconds. So while data loading is not the major thing we want to display here, but here we can already start to see the benefits of having a distributed system where you can use the cores, the disk, and the RAM across multiple servers to speed up your workload. So now that we are done with the preparatory scripts, we already have some data loaded. I'm going to open 2 files. This is going to be the commands I'm going to run on single node Postgres. And this is going to be the commands I'm going to run on Citus, that is the distributed tables. To start with, let's do a quick count of how many rows we have in the larger table, which is GitHub events. That will also help pull the data set and cache it so that we can have consistent performance across the future runs. So this, as I mentioned, this query is going to run against single node Postgres tables. As you notice, it doesn't have the _dist here. And then we're going to run the same count query against the distributed table as well. So as you can see, there's already performance improvements on Postgres versus Citus. Now that the data is cached, we should see more consistent performance runs. Let's start with like creating indexes. So the first index we're going to create is a standard B tree index. Let's go ahead and run this particular command. So it's going to create the index on the event type field, which is the field which houses what kind of events you're running right now. As you can see, it took about 1.5 seconds. And as you're familiar with relational databases, indexes have a huge impact on performance. And also, if you want to try out creating new index types, if you want to try out like whether a particular index will help on performance or not, having those index runs be faster also greatly helps. So let's go ahead and run this create index on the distributed table as well. So as you can see, it took about 1.5 seconds for this create index command to run on the non-distributed table, about 176 milliseconds for it to run on Citus. And that's because Citus is going to parallelize the create index command across the different nodes we have in the cluster. Now, the other index I'm going to create is going to be a GIN index on the JSON field. So how many of you, let me actually go ahead and run this. How many of you use JSONB in your Postgres schemas? I think you should have a poll pop up on your screen. Just wanted to understand so that I can decide how much to dive deeper into. I'll just take a 5-second pause for you guys to vote on this. Okay, so looks like it's around half and half. So there's about 60% of you who have used JSONB, about 40% who have not yet used JSONB. So JSONB allows you to store the data in a compressed, JSON data in a compressed format, which allows the ability for you to index it using these GIN indexes. And what the GIN indexes do is basically index individual keys within the JSON so that when you run queries on that particular key, you can use the index to get much faster read performance on this cluster. Now, creating and maintaining GIN indexes is more expensive than B-tree indexes, because now you have a very large field to index, which is where performance improvements on the index creation side greatly help in terms of being able to test these changes and do these things much quicker in a distributed setup. So let's give it about a few more seconds for this to go. If you guys have any questions, feel free to drop them in the Q&A tab. If there's some I can take right now, I'll take them. Otherwise, we will definitely take a bunch of them at the end. But if you have any questions right now, do let me know. Okay, so looks like the create index completed. It took about 110 seconds for this to complete. I'm going to go ahead and run this on the distributed table as well. So as you can see, this part of the query took 110 seconds. Now, when you run this query on Citus, now GIN indexes are computed much faster, because now you can use the capability of multiple cores. So here it completes in about 10 seconds, in contrast to 110 seconds, which it took on the single node system. So now that we have the indexes set up, I'm going to walk through a couple queries. The first one is just going to compute the total number of commits we've done on GitHub and broken down per hour. So let's start by running this query on a single node system. So this query takes around 757 milliseconds when run on the single node system. Let me go ahead and run this query on Citus as well. So it takes about 65 milliseconds for the query to execute on Citus. So as we can see, it's already greater than a 10x improvement in the read queries we ran. And let's look at a standard explain plan to see what caused these performance improvements. So again, this is standard Postgres explain. So if you were to run this query on Postgres, single node PostgreSQL, the explain plan looks very much like this, where you can see that it's going to scan the table, it's going to aggregate the rows, and then the final sorting step, that would form the explain plan if you were to run the explain on a single node Postgres table. What's different with Citus is, one, it's going to split up the query into 32 smaller chunks. And the number 32 is basically a number of shards you have in the system. So basically you have 4 nodes in the cluster, and each of those nodes has 8 shards each. So Citus is going to parallelize the query across all the 32 shards in the system to give you the performance improvements we talked about. So if you look at it here, because we are able to do 32 parallel queries, each of them running this particular query plan, we are able to get about 10x performance improvements for this query. The next query I'm going to run is going to be a join query, where we are trying to find the top 10 users who created the most number of repositories. So this query is going to join the events table with the users table and give you the results of the join and fetch only the top 10 users for this. Okay, so running this query on the single node Postgres, it takes about 382 milliseconds. We're going to go ahead and run this query on Citus as well. Yeah, so it's around 40 milliseconds for this query to run on Citus. So if you look at it here, this particular query was ran on single node Postgres system with 382 milliseconds and around 40 milliseconds on Citus. Again, walking through the explain plan, just to give you an idea of what these speedups are coming from. Again, a slightly similar plan where you see Citus splitting up the query into 32 chunks. What's interesting is one, the index creation and the index, the querying the index also gets parallelized across the different nodes in the cluster. The same thing holds for the join operation as well. So because we've sharded both the tables on user ID, Citus is able to push down the join completely to the data nodes to give you fast joins without having to shuffle data across different nodes. So as you can see here, so those were the primarily two queries I wanted to display. So with a small 4-node cluster, you can say performance scale pretty linearly across the different nodes we have in the system. If you want to add more nodes to the cluster and you can move the existing shards over to the new nodes, you can expect performance to increase linearly from there. So if we were to make this 4-node cluster an 8-node cluster, you could expect your query performance to be cut down in half. So with that, I'll take a quick pause to see if there are any questions. Okay, so I see that there's a question which is, could you explain the term shard again? So the shard is basically just a regular Postgres table. And the way it's named is going to be just table name _ shard ID. So I'm highlighting an example name of a shard on the screen. So like this particular shard lives on host this particular node. And this node will have 7 other shards. So Citus will equally distribute all the shards across the different nodes in the cluster. Now each table will have a set of 32 shards. So here we have 2 tables, each of them having 8 shards per node. Okay, with that, let me look at a summary of the kind of numbers we've seen. Okay, so this is the rough numbers which we see. This is around, the timings are in milliseconds, and then we're looking at the improvements here. Walking you through each of them. So we saw B-tree index creation. It's about 8 to 9x faster. The JSON-B gene index, which is more compute intensive, which took about 110 seconds, which is closer to 2 minutes on single node Postgres, about 10 seconds on Citus. The single table query, which aggregated and sorted a bunch of rows, was around 11.5x faster. The join query, it was around 382 milliseconds on single node Postgres, about 40 milliseconds on Citus. So roughly a 9.55x, around a 10x improvement. So as you can see, like with a basic 4-node cluster, these are the kinds of performance improvements you can expect with Citus. So that's a summary of what we had for this demo. I want to take you back to the slides. Okay, I'm looking at a question right now. Let me walk through one last slide and then we'll take a break and walk through all the questions we've received. Okay, so I wanted to just, after the summary, I just wanted to end with why I work at Citus and why I do what I do at Citus Data. So what we love doing and is basically helping developers solve problems around growth, scale, and performance. So we have a lot of like Postgres users come to us who are great fans of Postgres and who want to use it for much larger workloads, but they haven't been able to do in the past because it's been a single node system. What we look to do is help you to scale Postgres, continue to use all the goodness of Postgres while sharding it out and scaling it out across multiple nodes. And it's also great to work with all the people we have at Citus who are the smartest people I've worked with. We have Teresa here who started the demo, and she's been awesome to work with, and so have been all the other members at Citus. Thanks for your time again. Over to you, Teresa.
Thank you so much for joining us, and we look forward to doing another webinar soon. Thanks again. Bye.